Hey everybody, I'm Brian with Knox Company, and every time I make a video about how to add an outlet, how to move an outlet, I get the same question when people see this: the cutting out of the original box in the wall. And I've answered this many times in the comments. I go over the different theories and the different reasons why somebody might need to cut the box out of the wall, or why you might want to leave it there, but the things you have to look out for. So in this video, I'm actually going to do it. So I'm going to leave the outlet in the wall where it's at, add an additional outlet without cutting out the first one, and I'm going to show you how to do it the right way, some things to look out for, and also some parts or supplies that you might need. And as always, those will be down in the description in case you need to grab something. So let's first go over the situation that we have here, where it might be actually ideal to leave the box where it's at, eliminate a little bit of work, and you'll be able to easily put in the new one. So where we are standing right now is my new workspace. I do not have an outlet where I need it, which is right here where I have this heat press. This is my new workspace, studio, and design. This is going to be my new office and workspace where I'll be making the t-shirts that I produce. It's just something I do for fun on the side. I design and print myself. I finally have the website up, so if you do want to grab some gear, I'll put one of those shirts down here in the video description, and you can also check out more designs on the website. But what we're here for is how to put that outlet where I need it. I need an outlet right here above this counter space. I want to be able to plug in items at the top of the counter, and this is a normal bedroom, and I do not have any outlets that are up at that 36-inch mark. So what I want to do is bring some power up to that location, but the problem is the only outlet I have is about 4 or 5 feet off to the side, and it's down by the baseboard. And I really don't want to have to cut through the wall and do more drywall work to move this over and up to where I want. And as a side note, if you do want to know how to move electrical over and up, I have some other videos that explain that whole process, and I'll link those as well in the video description. But like I said, in this specific scenario, I know in the hallway on the other side of this wall, we have a media closet. They have a smart panel, which a lot of houses have now, where you can plug in all your camera systems and other things like that. So there's additional power there, and I believe that there's an outlet above the coat hanger area. So with that location and where it might be on this wall, it should land somewhere where I have this table set up. So what I first did is I just measured inside the room, and it was roughly about 11 feet to the doorway. And I went into my hallway and I measured 11 feet from that doorway down the hallway, and I could see that that outlet was within about 12 inches of where we were. So what I'm getting at is we need to locate where our original power is and then where we want our power. This is going to work and make it very simple if it's within the same space of where the studs are at. So if you have power on the same wall on the opposite side, it's very, very easy to jump that power across, and you may not have to remove the original box. So now that I knew that I had an outlet roughly in the area that I needed it, I then took out my stud finder and I wanted to locate the stud of which side it was on, so that I can then go to the wall inside this office and start finding out where that same stud would be. Fortunately, this landed right smack dab in the middle of where my table was. So all my measurements and my planning ahead of time allows me to make sure that I don't just start cutting holes in the wall or punching something through and it be completely off. So this is where we definitely measure twice and cut once. Now let's take a look at some of the items that we're going to need to do this job right. So starting from the beginning, we have our original types of boxes, and this is usually when you want to remove it out of the wall. We have to create a separation here, and we need to actually cut these nails off to get the box out. But we're going to be leaving this box at the original location in place. What we replace it with normally when we remove it are one of these boxes. These are called old work boxes. This is a little bit larger than this, as you can see. One reason I like removing this box is because we are starting with the original 14 cubic inches, and we can upgrade to the 20 cubic inches. And why that's important is because we're going to eventually have more sets of wires coming into this box. And when you have 2, 3, 4 sets of wires in this 14, it's a lot harder to work with, and it's easier when you have more space to tuck those wires back. So one reason to also remove this is so that you can upgrade to this, because these are usually not what's built in your house. And while we're talking about this is why we are able to leave this box in place. We are going to be removing, if not opening up more, but I would try to remove this tab so that as you knock out that tab in the back of the box, you have a place to run your new wire, and you do not want it to grab on the wire. You can see on these, the tab is not meant to be fully removed. It's still connected right here, and you can open it up right there. So it creates a little push down, and as you pull the wire back, it'll snag. With a lot of these boxes, you can actually open it up completely and take the knockout completely out. This is more ideal because you can feed that wire through and you don't have anything working against you. But if you have to, you can take those pliers with your original box still there and get your pliers back there and break off that plastic or open it enough so that you can actually push that wire through. But that is how we are able to do that by leaving the box in. We're going to use one of these knockouts and push the wire through. We also have our circuit tester so we can test it to make sure the power is off, and then also test it once we have the power back on. We have this fishing tape. If you don't have one of these and you do electrical work, this is also one way to find that wire. In this case where we're running the wire through a box, it should be a short distance and it shouldn't be through many obstructions. But if you do, you can use this through the box, pull the wire back through. But again, pulling that wire through a box that's already in place can be difficult. So this is why we're just going to be doing it with the wire itself. We also have our new outlet. I like using these now. These are Leviton Decora. They have these quick connections where you just push the wire in and you close it down. They're nice, they're clean, they're kind of updated. When I make those wire connections, I like using these. These are Wago lever nuts. They are very quick, but most importantly, they are very slim. So while you're connecting your wires, you can tuck all your wires back in and it takes up a very small amount of space in the back of the box. So that's why I like using these, because of how small they are. We're obviously going to be using our yellow 12-2 Romex. It's going to be used for most of your outlets. And if you ever see the white wire, people always ask which is which. White is a little bit smaller. It's a 14 gauge. You're going to use that in your ceilings and lighting applications. When you use this is for a little bit more power and it's going to have a larger gauge wire. It is a 12-2. So 14-2 is white, 12-2 is yellow. Yellow is what you'll normally see for outlets. And then obviously we can use our multi-tool or whatever your choice is, but these are quick and easy and it allows you to usually make a pretty clean cut. So when I am cutting through drywall, I usually use this type of tool now. Now that we know that we have the power in the area that we want it, and what we're gonna do is bring that power from the upper location and bring it down to right above where the countertop is, we first wanna turn the power off. Always turn the power off on these things before you work on any electrical circuit. The next thing I'm gonna do is really make sure that this is exactly where I want, because we all know that our measurements could be slightly off. So before we get super invasive, this is a little trick that I have here that I always do to mark exactly where we're starting, and then I can measure on this wall where I want to go and making sure that I'm in the right space. I'm going to unscrew and remove the original outlet out of the box just far enough so that I can see those knockouts in the back of the electrical box. You may need to take some needle nose pliers and remove the tabs that are sitting in the back of that box so that we have enough room. But what I'm going to do is create some space so that I can take a screwdriver or some type of mark-all, something thin and sharp that you can actually push through that knockout through to the back of the wall, and you're going to just poke and wiggle it through that drywall so that it pokes through the other wall. So I do that here, and then I come back into the office and I can see that it lands right on that wall, and I have a physical reference point of where that electrical is and where we're going to be moving it to now. And now we know that we're on the money. Now we know that the power is where we want it. We're not going to make any mistakes, and so that when we do open up this wall to put in the new outlet, we're going to cut once and we're not going to have any mistakes. So now all we have to do is start marking the location of where we want our new outlet. You're going to do this by just marking around the outer perimeter of your old work box. We are going to mark the smallest area first. That way we can cut that out, and then if we need to, we can remove a little bit more material, because obviously if we cut too big the first time, we may have that drywall work to repair. So cut small and then work your way out if needed. But marking the perimeter on these boxes and cutting it out is pretty straightforward, but always start small. And now that we have the opening, we can go ahead and test fit our old work box. If you do need to adjust, make those adjustments now. A lot of times when you put in that old work box, it will get stuck. It's because those tabs will just kind of fall down. So when you go to pull it out, even though you haven't tightened it, it will get stuck. No problem. Just take a screwdriver, turn it so the tab comes back up and you can pull that box out. Now here is where we get ready to run that new power cord. We are going to run a 12-2 Romex. That is usually your most common yellow wire that you'll see. And again, we're leaving the box in place, and this is where you might get some criticism. I know that I will in this video. I'm going to be running my wire through the knockout that is already being used by a wire. And I know that code might say that you are not supposed to put 2 wires through one knockout. Most boxes have 4 entries in the back and you use 1 for each set of wires. Any more than 4 would be too much for this box. We are going to be bringing that up to 3, obviously, because we have power coming in and then we have power going out to the next circuit. But at this box, we're going to be bringing power down to the new location. But that's what I'm getting at, is that this is where it is either ideal or not ideal to do this method. If I had to run power up and I didn't have any ability to move that wire or to get that wire through the upper knockout, I would have no choice but to put 2 wires in one hole, or I would have to figure out something and make a new hole, which you should probably not do. The idea is that when you're using this box in its place, you are restricted to the angle at which you can push through, and it is going to bind up a little bit, especially if you already have another wire in that spot. So this is where it either will work for you or won't work for you. What you do need to do is use the knockout that correlates to the direction that you want to push your wire, because otherwise it will work against you. You will not be able to feed your Romex wire through the bottom and up behind your outlet box. It will just bind up too much on you, and you will spend way more time fighting that wire than you would have just removing that box, having more room to work with in the wall, and then putting in another old work box here when you're done. So that is why a lot of people will just remove the original box, have a whole bunch of space to work with. You can reach and feed your wires in and alleviate a lot of problems and save some time. You're not working in such a confined space. And at the end of it, if you've ever fought through this stuff, you'll realize that cutting out the box and putting in a new one would have been a lot faster. So yes, here in this video, I'm going to run my wire through that bottom knockout, and I'm just gonna feed it down, and I even bend the Romex slightly in the angle because I plan on it hitting that wall, and I need it to kind of self-correct, so as I'm pushing, it will guide itself down. Also, to help me know how much wire to put into this wall before I can go check and try to fish it out, I marked the distance from the original location to the new location on my Romex, so that as I fed the Romex wire through, I knew that I had enough in the wall that I should be able to see it at the new opening. So I just fed that wire through. Luckily, it did not bind up on me that much, and I was able to get it in there easily, and then I was able to come into this side of the room and actually find it right there inside my wall and pull it through the new opening. Now the hardest part is done. We've made it. We left the original box. We got the new wire. We have the wire that's now added coming through the original location. We have our fresh power source here at this wall. So while we're here, we can go ahead and just finish this up. Feed your wire through your old work box, push your old work box into the wall, secure it in place, strip back your wire, go ahead and wire up your new outlet. I like using these new push connects or quick connects. They have the little tabs that you just open up, black to black, white to white, ground to green, and then you can put it right in there, put your faceplate on, and we're all done at the new location. Now we can go back over to the original location and get everything wired back up, but we also have 3 sets of wires now, so that's where, again, some people have some trouble. I like to use these Wago quick connects. They have little tabs again, and you can actually feed your wire in, and it's very fast. But the reason I like it is because once you start adding more wires to these boxes, those larger wing nuts that have to take 3 or 4 sets of wires, they are very, very big. So as you're tucking your wires back into the box, it starts getting very crowded. And then when you try to put your outlet back in there, it'll not have any space to actually screw in correctly. So I like these Wago connectors not just for the speed and the easiness, but I like it because they are space savers. And here's something for you guys. If you have never wired multiple wires together, there's a method that I believe is called a pigtail. If you know what a pigtail is, maybe you can put it in the comments below and see if I'm correct or see if maybe I'm missing something. But this method is, I believe, referred to as pigtailing. But what you're gonna do is take those 3 black wires and you're gonna put them together, and you're gonna come off with a 4th wire. This joins all the black and it puts it together, and you have 1 lead or 1 main line coming off to power this outlet at this location. But that power source is shared amongst all 4 wires. So you'll see here with the Wago connector, I have all 3 coming in, and then I have 1 nice clean one coming off. This also allows you to trim your wires a little bit shorter, so again, saving space. And as you have them there all connected with 1 lead coming off, I fold them back and I tuck it nicely flat on the inside of the box. And then I do the same thing for the white wires and the ground wires. And I think the reason they call it pigtailing is because normally you would actually have 3, 4 wires and you're winding and you're twisting them up together, and it has like a pigtail corkscrew look. I think that's where the term comes from. But again, if I'm wrong, correct me, let me know what I'm missing here. But this is the method to connect those wires the right way and have your power source coming off, and you don't have 3 or 4 sets of wires all connecting to that 1 outlet. You have 3 sets of wires and 2 places to screw them into, and what we do not want to do is start doubling up under those terminals. So that cleans it up a little bit, and it allows you to have just 1 connection to the outlet, then everything else can be bound together and tucked away. So now that we have everything connected correctly, we have our 3 lines coming out of the box, we can easily connect that to our outlet, tuck everything in, secure the outlet, put the faceplate back on, and now we are done. Your last step now is to turn the power back on and check your outlets, and as you can see, they are both working perfectly. And that is it. We are all done here. Hopefully you found that helpful. If you have any questions, please let me know in the comments. I'm very good at getting back to them. As I mentioned earlier, I do also make t-shirts on the side for fun. I draw, design, and print them all myself, so if you want to grab a shirt, I'll link them in the video, and you can also visit fortknoxcompany.com and you'll be able to see all the other designs there. Either way, I appreciate you watching. Make sure that you subscribe, hit like, and I'll see you on the next build.